let's talk about some specifics of electromagnetic waves. Previously, we said that electromagnetic waves can travel through a vacuum, but that's not all they can do. Different electromagnetic waves will interact with different types of matter in different ways. Let's think about visible light, for example. If I shine some visible light onto a white surface, most of it will be reflected off. If I shine it onto a black surface, most of it will be absorbed. If I shine visible light onto a piece of glass, most of it will be transmitted through the glass. Some of it will be reflected backwards, and the light that goes through it will be refracted slightly. However, if I shone gamma radiation at these three things, it would probably be transmitted through all three of them. And if I shone infrared radiation at all three, it probably wouldn't be transmitted through any of them. Now, I'm not going to go into too many details here because there are countless combinations of the different types of electromagnetic waves and different types of matter and how they all interact. But just know that different substances can absorb, transmit, refract, or reflect electromagnetic waves in a way that varies with the wavelength of that wave. But a nice example of this is X-rays when they're used in medical imaging. Now, X-rays will transmit through soft tissue like skin and flesh, but X-rays are absorbed by bones. So if I put a special photographic plate behind a person and then shone X-rays through the person at that photographic plate, the photographic plate will go dark everywhere that the X-rays hit. And since the X-rays can go through the soft tissue, it will go dark there, but the X-rays are absorbed by the bone, so it will stay white where the bone was. This is how we can build up those skeletal images that we use in hospitals to investigate injuries. Let's talk a little bit about producing and absorbing electromagnetic waves for communication. Let's look at radio waves, for example, because radio waves are the lowest frequency waves. And it turns out we can actually produce an electromagnetic wave by making an electron wiggle. If we wiggle an electron, it will cause a wiggling electric and magnetic field as well, which is just an electromagnetic wave. So the frequency that I wiggle an electron at will produce an electromagnetic wave at that frequency. So since the radio waves are the lowest frequency, these are the easiest ones to produce. So we can get an aerial and put an alternating current through it, which will make the electrons wiggle at the frequency of the alternating current. It will just produce a radio wave at that frequency. And then we can do the opposite at the other end. We could put an aerial somewhere, and wherever radio waves pass through it, it will make the electrons wiggle in that way, and we can then read that off as an alternating current and feed it into a machine like a speaker or like an old-fashioned TV. This is how television broadcasts used to work and radio broadcasts used to work. We switched to digital now, but the principle still remains. In fact, microwaves are used for satellite communications, for Wi-Fi, and for mobile phone communications in a very similar way. Let's just go through a couple of other electromagnetic waves and some of their uses. Infrared waves can be used as heaters. They can even be used to cook food because infrared radiation is a type of heat transfer. Visible light can be used for communication in fiber optic cables as well. We can use something called total internal reflection to make light bounce down the inside of a fiber optic cable, and we can send flashing pulses through that. That's how a lot of broadband works these days, in fact. Ultraviolet light can be used in energy efficient lighting, can be used in security lights. It can be used in tanning beds as well, although that is a little bit dangerous. It can cause skin cancer. And finally, gamma rays can be used to treat cancer by targeting specific cells, targeting tumours, killing the cells in the tumour without damaging the surrounding tissue. Electromagnetic waves are used in a whole manner of different ways, and it's quite a good idea to be familiar with a few of the basics.